Welcome to Chapter 1.2, Part 1A, and this is going to be more about bases and converting bases. So here we're going to look at some what's called base 5 blocks. And base 5 blocks work a lot like base 10 blocks, except they're based in, guess what? 5. So the ones are the ones, so we have the ones, and then we have 5 to the 0. Well, as I said, anything to the 0 power is 1. Then we also have rods, okay? And these rods, instead of being made up of 10 parts, they're made up of 5 parts. So that's going to be 5 ones make up a rod, or 5 units make up a rod, and that would be 5 to the first power. Then the flats in base 5, well, that would be the 25s. And so 5 of the rods make one flat. So 1 flat is made up of 25 units, or 5 to the second power, or 5 squared. And then cubes, well, that's the 125s column, and that would be 5 flats make up 1 cube, and then 125 units make up a cube, and that's the same thing as saying 5 to the third power. And again, in the physical world, we do not tend to go higher than this, so this is where our block world tends to end. In example 1, we're asked to make 213 base 5 using base 5 blocks and then convert them into base 10. So let's look at the whiteboard and see what we mean by this and how we're going to do this.
What I did here in example number 1 is I took the number 213 base 5 and I set it up in terms of blocks. So I made, since it's base 5, that means that a flat, or the 25s column, will be 5 by 5. So that would be the 200 part, or the 25 column. So flat, and so there's 2 of them, so that's what the 200, the 200 means. Then the next column would be the 5s column, and that means there's 1 rod, and so the rod, which is 5. And then finally the units, and then there are 3 units. So if we're going to convert this into base 10, we're just going to count these up. So we see we have 5 by 5, this is the 25, and there's 2 of them, so that means that that's 50. And then we have 1 5's rod, so that we add 5 to that, and then we have 3 units. So if we add 50 plus 5 plus 3, we get our final answer, which is 58. So that means that 213 base 5 is 58 base 10.
To summarize what we just did on the whiteboard and computer program, we represent 213 in base 5 blocks as 2 flats, 1 rod, and 3 units. But what this actually means, because we're using base 5 blocks, that means we have a 5 by 5 flat, which means there's 25 here, 25 here, and then the rod has 5, and then our units. So that means we have 25 plus 25 plus 5 plus 1 plus 1 plus 1, and that's the same thing as saying 2 times 25 plus 1 times 5 plus 3 times 1 is equal to 58. Now, another way to do this, besides using blocks, because as things become more and more complicated, blocks can be very, very cumbersome. So we want to be able to do it using a table. So let us go to the whiteboard and show how we can do it more simply by just using a table.
In example number 1, I'm now going to work out what I did in blocks. I'm going to use a table. So I'm going to make a table. For 2, 1, 3, base 5. And notice how I put that little 5 on the bottom there to tell me that I'm working in base 5. Now, this column here is represented 5 squared. This column here is represented by 5 to the first power. And the final units column is represented by 5 to the 0 power. Now remember, 5 squared is 25. 5 to the first power is 5. And 5 to the 0 power, well, anything to the 0 power is 1. So this represents the flats that we used. This represents the rods that we used. And this represents the units that we used. So what I'm going to do is I'm going to take this number 2, 1, 3 and put it in its proper column in my boxes here. Then I am going to take 2 and I'll multiply that by 25 because that's what that represents in our base 10. Plus, now I'm going to have, I have 1 and I have 1 rod, which is represented by 5 in our base 10. And then I have 3 1s. So that means that I have 2 times 25, which is 50, plus 1 times 5, which is 5, plus 3. And then I add these up. 50 plus 5 plus 3 will give me 58. So that's how to do what I did in blocks using a table.
Now let's summarize what I just did on the table. So here I had set up my table, as I said, and here's my 5 squared column, my 5 to the first column, my 5 to the 0 column, and I write in my 2, 1, 3, and then I go, just like I have here, 2 times 25, because that's the 25s, and then 1 times 5, because that's the 5s, and then 3 times 1, because that's the units or ones. In example number 2, we're asked to convert the number 311 base 5 into our base 10 system. So what I'm going to do, I'm first going to show how one does it using blocks, and then I'm going to show how one does it using the table. It's usually best to do it by the table, but the blocks give a visual representation, and some students like to see the visual representation first and then work it out on the table. So I am going to do it this way. So let's go over to the blocks and look at the blocks first, and as I said, then I will work it out on the table.
So here I set up 311 base 5 using our blocks. So for the 25s, I have 3 flats. Each one of these flats consists of 25 units. So that would be the 3 in the 3, 1, 1 base 5. Then for the 1, well, it tells us that there's only one base 5 rod. So here I have my 1 base 5 rod. And then finally, in the units, it tells us we only have 1 unit. So then I add these up. So 25, 50, 75. 75 plus 5 is 80. And then finally the 1. So that gives us 81 base 10.
Now that we have seen how it would look using blocks, let's go now to the whiteboard and work out how we would do it using a table.
In example number 2, using a table, we'll take 3, 1, 1, base 5, and notice I have to write a little 5 over there to remind me and to tell everybody that that is base 5. So again, I'll make a table. And in this case, my highest one is in the it's 1, 2, 3, so that's 5 squared. And I have 5 to the 1s, 5 to the 0 power, and 5 squared is 25, like we saw with the flats. 5 to the 1 is 5, like we saw with the rods, and 5 to the 0 is 1s, like we saw with the units. And in this case, we have 3 of these, so it will be 3 times 25. And I have 1 rod, so that's 1 5s. And then I finally have 1 1. And then I'll write 3 times 25 is 75, plus 1 times 5 is 5, plus 1. And then I add them all up, and I get 81 base 10. And base 10 is our number system. And since it's our base that we essentially live in, we usually just write plain old 81. We don't have to write the base.
So to summarize what we just did using the table, we were going in the opposite direction. So here we use the same base 5 table that we used in example number 1, but now we multiply the 3 from the 25's place by 25 to get 75, the 1 from the 5's place to get 5, and the 1 from the 1's place to get 1. So now we add 75 plus 5 plus 1 to get 81 in our base system. So here's the table in summary, and this is just a summary of what I just did on the whiteboard in much greater detail. In example number 3, we're asked to convert the number 81 into base 5. And like I did in the former example, I'll work out on the whiteboard using the blocks that I found online and show you how it's done by blocks, and then I will work it out on the table, and then I will summarize the table just like I did in example number 2.
For example number 3, in showing this example using blocks, I set up 81 in terms of its base 10 blocks. So I have 81 is 1, 2, 3, 4, 5, 6, 7, 8 rods and 1 unit. Now, what I would like to do is I would like to now see how many 25s I could get out of these 8 rods. So I'm going to have 1, 2, 3, 4, 5. So that gives me 1 base 5 flat, or a 25. I'll do another one. And so here I have 1, 2, 3, 4, 5. So this gives me another 25, or base 5 flat. So that'll be my 25s. And then I'll do another one. See how many I can squeeze in here. Put this unit over here. 1, 2, 3, 4, 5. So this will give me another base 5 flat. So these are my 25, and I have 1, 2, 3 base 5 flats, and I have left over 1 base 5 rod, and that's my 5s column. And then I have left 1 unit. So this is 1, 2, 3. So that would be 3, 1, 1. As you can see, it's a little more complicated using blocks to convert from base 10 into base 5. It is actually easier to use a table, and that's what we will show in the next part.
Now let's look at how this would be done using a table.
In example number 3, we're asked to convert 81 base 10 and find what is it base 5. So I'm going to make a table. I'm going to use a table to do this. And my table will be 5 squared, 5 to the first power, and 5 to the 0 power. And 5 to the 0 power will be my 1's place. 5 to the first power will be my 5's place. And 5 squared will be my 25's place. 25's place. Now we have to ask ourselves how many 25s go into 81 without going over it. So we say to ourselves 81 divided by 25. Well, that can go in 3 times. And 3 times 25 is equal to 75. Now, if I add another 25 to that, I will end up with 100, because 4 times 25 is 100, and that's too high. So that means we will have here 81 divided by 25 will be equal to 3, but there will be a remainder. So how do we figure out what the remainder is? Well, we subtract. We take 81 and we subtract 75, and we find that the remainder is 6. So we have a remainder of 6. Now we take that 6 and we divide it by 5. And again, we want to see how many 5s go into 6, So we have here 6 divided by 5 is about 1 with a remainder of 1. So we have the same idea that we want the whole number, and then we will bring the remainder over to the next column. So this will be 1 with a remainder of 1. And then finally, we'll have in the ones 1 over 1. Well, that will be equal to 1. Now we look at our table and we see, we're going to look at all the whole numbers that we found. And we see that we had 3, 1, 1. So 3 from here, 1 from here, and 1 from here. And then, of course, we write a little 5 down there, which is very, very important because we have to know what base this is. If we don't write anything there, it will be assumed to be base 10. And that's not what we have here. What we have here is base 5.
So let's review what we just did on the whiteboard with the table. And here we are going in the opposite direction. And we start by thinking how many 25s go into 81 without going over it. So that means 81 divided by 25 is 3 with a remainder of 6. Now we go to the 5s. So we take this 6, we divide that by 5, and we see that 5 goes into 6 one time with a remainder of 1, which now we take that 1 and put it in the 1's place. So here's our summary of the table that we just did on the whiteboard. And notice that when we're talking about a base 5 and we converted it into base 5, we must put this little 5 here. Otherwise, it will be in base 10, which is not what it means. In example number 4, we're going to convert the number 127 into base 5. And again, for those who want to see it using blocks, I'll show you first using blocks using the program I found online, and then I will work it out using the table, which is the way, a quicker way and a more efficient way to work these things out. So let's now go to the whiteboard.
For this example, since I cannot draw any cubes, we see here that the 5 cube place can be taken up by all of these. So this would be 5 cubed, which would be 125. So that will be one of those, 1 cube. We don't have any 25s. We don't have any 5s, and we only have 2 units. So there are 2 units, and here is our 5 cubed, or 125, and no 25s and no 5s.
Now I'm going to work it out on the whiteboard using a table.
Here we have 127, base 10, and we want to figure out what it is base 5 using our table. So the question, when you look at 127, you want to see how far out you have to make your base 5 table. Well, we see that we'll start making our table. Well, we certainly see that 5 to the 0, that there are certainly 1s there. And we go 5 to the 1. We certainly have, 5 can go into that. 5 squared, that means 25 can go into that. And then 5 cubed, and 5 cubed is 125, so we're going to need the 5 cubed. But any higher than that is too high because it goes above 127. So we know to end it at 5 cubed. So I'll end my table there. And as I was saying, as I was going along, 5 to the 0 is our 1's place. 5 to the 1 is our 5's place. 5 squared is our 25's place. And 5 cubed is our 125's place. And as before, we're going to figure out how many 125's go into 127 without going over 127. And it turns out that there is 1. So we have 127 divided by 125 is equal to 1. And there's a remainder of 2. Now we take the 2 and we put it in the next column, 2 divided by 25. Well, 25 cannot go into 2 as a whole number. So we'll just put 0 here. And we'll just carry it to the next column. 2 divided by 25, 2 divided by 5. Well, again, 5 cannot go into 2 as a whole number. So that's 0. So we'll carry the 2 finally over here, 2 divided by 1. And here we have now is equal to 2. So that means that we have 1, 0, 0, 2, and that base 5. So 1, 0, 0, 2, base 5 is equal to 127 base 10. So they really do mean the same things. Of course, as you see, it's much easier using a table than using blocks.
Summarizing what I just did on the whiteboard using the table, we use the base 5 table, but now we have to go up to 5 to the 3rd power, or 120, or the 125's place. So that means we have 127 divided by 125, and we get 1 with a remainder of 2. This means that there are not any numbers in the 25's or the 5 place, so we put 0 in those places and then put 2 in the 1's place. So here's our table summarized, just like written much neater than I had on the whiteboard. And here is our final answer, 1002 base 5. And remember, you must always put this little guy in over here in order to tell what base it is. Otherwise, it will be assumed, if you forget to put it, it will be assumed to be base 10, which is not what this is. In example number 5, we're going to go the opposite direction, and we're going to take 1002 base 5, and we're going to convert it back into base 10. So again, I'm going to show this, how this is done by blocks, and then I will show how it's done using a table.
In example number 5, since I was unable to do the base 5 cube, I just put it in terms of its base 10 blocks. So what I did is I decompose the cube, the base 5 cube, into 1, 2, 3, 4 25s, and that makes one base 10 flat. And then the other 25 I was able to make into 2 base 10 rods, and then 1, 2, 3, 4, 5 units. And here is my other base 5 25. So here for this one in this place here, which would be 125 or base 5 cubed, I have 1, 2, 3, 4 25s, and then 5 25s, which makes 125. And then here are the 2 units from here. So now we have it in a base 10 block configuration. So that means we can write this as 127 base 10, but we usually write it as 120, just 127. So this one was the 100 plus 10 plus 10, which makes the 20, and then here are the 7 units. 1, 2, 3, 4, 5, 6, 7.
As you can see, using blocks can get very complicated, especially if you go beyond flats. And regular numbers and base numbers can actually be much, much larger than just the flats. So that's why we're going to now do the table, and the table is really the preferred method in converting bases. So let's go to the whiteboard and work the same thing out using a table.
In this example, we're going to take 1002 base 5 and convert it into its equivalent in base 10. So we're going to again make a table. Well, how big a table do we have to make? Well, let's fill in the numbers. We have a 2 here. We have a 0 here. We have a 0 here. And we have a 1 here. So that tells us what our places are. So that means we have 5 to the 0 power, 5 to the first power, 5 to the second power, 5 to the third power. So there is our table, and then we say this is 1. Anything to the 0 power is 1. This is 5. This is 25. And this last is 125. So this is the 125s, this is the 25s, this is the 5s, this is the 1's place. So there are places in base 5. Now, as we did before, we take the first one and we multiply that by 125 plus 0 times 25 plus 0 times 5 plus 2 times 1. So that's equal to 125 plus 0 plus 0 plus 2. So that's 125 plus 2. So that gives us 127 base 10. But we usually will just write 127 since this is our usual base.
Summarizing what we just did on the whiteboard. So we use the same base 5 table as we did in the previous problem, but now we multiply the 1 from the 125's place by 25 to get 125, and 0 from the 25's place and 5's place to get 0, and the 2 from the 1's place to get 2. And then we add 125 plus 0 plus 0 plus 2, and we get 127 in our base system. So here's how the table looks in a much neater form than I did on the whiteboard. Thank you very much. I hope you enjoyed this video, and I hope you understand a little bit more about doing bases than you did before. And take care, and bye.